Well, hello and welcome to this exercise on vector equation of a straight line in 3D, an iGCSE type question here. Now, it says find the vector equation of a line with points A 211 and B 523. My three axes and my straight line, and my line, sorry. Now, firstly, can I just apologize in advance that I'm going to do this in one slide, and therefore there's going to be a lot of congestion here, so bear with me. Anyway, the equation of a line in 2D we know as y is equal to mx plus c. Now, we can rearrange this in the format of y is equal to c plus xm. Now, there's no difference between these two. Same thing, really. So what I'm going to try and do is to form an equation in 3D in this format here. Now, firstly, what I need to do is to find the position vector of point A. Okay, so the coordinates of A will be 211 as given to us. Now, this piece here is the vector OA. Okay. Now, the coordinates of B are 5, 2, 3. Now, to find the position vector of A, we know that at the origin there, the coordinates of the origin are 0, 0, 0, and hence the position vector of, or the components of the components of the position vector of A will be the coordinates of the origin will be subtracted from the coordinates of A there. So we then do 2 minus 0 is 2, 1 minus 0 is 1, 1 minus 0 is 1. So the components of the vector of this position vector of A are 2, 1, 1. Now, so that is position vector of A, or if you like, vector OA. Now, this OA here, this OA there, this vector there, is equivalent to C in the equation of a straight line in 2D. So that is the equivalent of C. Right, moving on from that, we now need to find the vector AB there. Now, to do that, we should subtract the coordinates of A from the equivalent coordinates of B there. So we then do 5 minus 2 is 3, 2 minus 1 is 1, and 3 minus 1 is 2. So that there, this one here, is now the components of vector AB. Now, if we call vector AB D, so D is now the direction vector of the line. Now, this D here, the direction vector, is equivalent to M in the equation of a line in 2D geometry. Okay, so in effect, lines with the same gradients are parallel in 2D. Similarly, in 3D, lines with the same direction vector are also parallel. So you can see the similarity there. Okay, right, now moving on from that. Now, and that is the D, by the way. This is the D there, direction vector. That's the length there. Right, now what then happens if we have a point, an arbitrary point of the line AB extended. So C is there. So that's our C there. Now, we wish to go from O to C, but so far we do not know anything about vector OC. So what do? We have to go from O to A, down the direction vector, up to C. So this is not unlike what we did in 2D vector geometry. Okay. So now OC will then be vector OC will then be vector OA plus a multiple of the direction vector. So we're going to add this vector AB there, and again there as well. So that's what we got there. So to go from O to C, we go vector OA and vector AB, and then a multiple of vector OAB. So OA plus a multiple of vector AB. So this multiple we have there. Now T, this T there, this T we've got here, this T is equivalent to the X in the equation of a line in 2D. Okay, so OC is an equal to, that should be equal sign there by the way, vector OA plus a multiple of the direction vector. Okay, now what happens if we need to find the position vector of C prime being a point on the line, but on the other side of the direction vector. So we're going against ourselves. So what we then do, we have to go via OA and then double up on ourselves and go down the opposite direction to vector AB. Okay, so in effect, this is what we've got there. We want to find the direction vector of OC prime. So OC prime would then be OA, vector OA, minus a multiple of the direction vector. So OC prime will then be OA, vector OA, sorry about that, sorry, is equal to vector OA minus a multiple of the direction vector D. Okay, so that's what we got there. So now, if we say that OA is R sub A, vector R sub A, and OC is vector R sub C, we end up with this equation here. That RC, vector RC is equal to vector RA plus a multiple of the direction vector, this one here. So that now is the equation of a line in 3D space. So what we then got is that the RC there is equivalent to our Y in 2D geometry there. And RA is equivalent to C, okay, and TD is equivalent to XM in 2D geometry there. Okay, so in effect, so that now is the equation of a line in 3D geometry. Now, I hope all that made some sense, and please subscribe. Thank you for watching. and bye-bye now. Bye-bye.